In this video, I'm going to be going over how to complete your Unit 5 review Part 1B. So basically what I have done here is taken your Part B assignment and kind of change some of the numbers, change some of the wording a little bit. What you'll be seeing is some very similar questions, but it's not exactly the same as yours. So again, make sure that you are not copying everything that I have, otherwise you will get points deducted because what's on here is not exactly the same as what is on your assignment sheet, but it is very similar. Okay, so starting with the proportional versus non-proportional page. First, let's look at the graphs. So to review, it says to sketch a graph that illustrates a proportional relationship. For this part, all you need to do is make sure that you have a straight line going through the origin. It doesn't have to look exactly the same as mine. Actually, I would prefer it not to look exactly the same as mine, but as long as it's a straight line going through the origin, it is proportional. For a non-proportional graph, you want it to do at least one of the two things. If you do both, that's fine as well. So it should not start at the origin. So if you start it somewhere other than the origin, or it needs to not be a straight line. Okay, now I have done both in my example. I started it somewhere that is not the origin and I made it not a straight line, but that is how you should draw your non-proportional graph. Next, for the tables, this one's asking you to create a table that illustrates a proportional relationship. So I just put my x values in, I gave myself a constant of proportionality of 2, and then put the y values. I know this table is proportional because it has a constant of proportionality. Again, you should use different numbers for your tables, but just make sure you do have a constant of proportionality going all the way through the table. For my non-proportional table, again, I put numbers in the table in which they would not have a constant of proportionality. So I made sure that my x could not be multiplied by the same number every time to get y, thus it is non-proportional. All right, next, for the written situation. Write a situation that illustrates a proportional relationship. So for this part, we just need to make sure that there is a unit rate. You could do something that has to do with cost. You could do like heartbeats per minute, any sort of rate. So this example, I said Nicholas is buying candy bars for $2 a piece. So every candy bar is $2. That's a constant rate. For my non-proportional relationship, one way you could do it is having a starting value, then a constant rate. Because remember, it can only be a constant rate. If you have a starting value plus a constant rate, it is non-proportional. So for mine, I put Nicholas buys a bag of chips for $3 and candy bars for $2 a piece. So that one, he's paying the $3 plus $2 per candy bar. Thus, that is not proportional because it's not going to be a constant rate. For the equations, you just need to write an equation for the two situations you had. So for mine, when Nicholas was buying candy bars for $2 a piece, the total cost was equal to $2 times the number of candy bars. When he was buying a $3 bag of chips, then $2 per candy bar, the total cost would equal $3 plus $2 times the number of candy bars. All right, the next section has to deal with identifying the constant of proportionality. So in a graph, remember, we can get the constant of proportionality by locating a point on the graph and using the coordinates. Okay, constant of proportionality is always y divided by x. So for this example, I chose the point you see here. The y value is 9 and the x value is 6. That could be written as 9/6 or 9 divided by 6, which is 1.5, or it could be written as 1 3/6 or 1.5. All four of these numbers are what we call equivalent values. They all have the same worth, so they're all technically correct. So the constant of proportionality in this graph is 1.5, and then writing it as a unit rate, that means 1.5 heartbeats for every minute. Okay, so 1.5 heartbeats, or sorry, second. 1.5 heartbeats per second. All right, next for the table below displays the distance that Emma walks over a period of time. So number of hours is going to be x, and then the distance that she walks in miles is going to be y. Step 1 says use the information given to determine the constant of proportionality. What is the constant of proportionality? So for this one, remember you need to do y divided by x, so 2 divided by 5. That could be written as 2/5 or 0.4. Both are correct. Use the constant of proportionality to fill in the rest of the table. Well, once I knew that my constant of proportionality was 0.4, I multiplied all my x values by that in order to get the y values. The constant of proportionality represents that Emma walks 0.4 miles per hour. So if I had 1 hour over here, my distance walked in miles would be 0.4, which is my constant of proportionality. All right, next for the equation, write an equation to match this situation. So for this one, it gives you one of the, we can think of it like if we were in a table, it would give you one of the ratios in the table, but it's not necessarily giving you the constant of proportionality right off the bat. So James spent $65, which is his total cost, on 4 video games, which is the number of video games is G. So we need to write an equation that would help us determine the total cost for any number of video games. So in order to do that, you need to find the unit rate. So I did the cost, which is $65, divided by 4, which was the number of video games. So I know each video game costs $16.25. Once I have that unit rate, I can write my equation. The equation should be C equals 16.25 G, because the total cost is equal to $16.25 times the number of video games purchased. The next one is about writing equations 2 ways. So this situation says that Bella spent 3 hours making 1 batch of cookies. So you really just need to think critically about what makes sense here. So the first one is H equals 3B, because hours is equal to 3 times the number of batches, right? 3 is equal to 3 times 1. So that's the first one. Thus, if we were to flip and put the variables in a different order, the batches, in this case is 1, is equal to 1/3 the number of hours. So really, once you have this one, the little trick is that for if you switch the variables, it's going to be the reciprocal, right? 3/1, 1/3, those numbers are reciprocals. Okay, and then this one, write a situation that matches this equation. So this is going to be kind of tricky. So it says, do not use the constant of proportionality in the written situation. Use another set of numbers that would hold true for this equation. So see the written situation in the equation section as a guide. So kind of like over here, how in the situation it gave us 65 and 4, but the actual constant of proportionality was 16.25. Here we have 2.5, and we're going to have to use a different set of numbers that would still hold true for that constant of proportionality. So because I know that y is the total cost and x is the number of candy bars purchased, I know that the total cost needs to equal 2.5 times the number of candy bars purchased. So I just chose a random number. I chose 5 candy bars and multiplied it by 2.5 to get a total cost of $12.50. So it says so my situation that I wrote is that Emma purchased 5 candy bars for $12.50. So because $12.50 divided by 5 would give me $2.50 per candy bar, I know that the equation y equals 2.50x would hold true for my written situation. All right, we're on the last page here. So it's a little hard to tell the colors, but you can see as I do them what they are. So for this one, you need to fill in the points and then explain what they are representing. So the blue dot is at the coordinate point 230. Remember, x comes first, then y. So the coordinate point 230, and that means that Miguel, I got that information from the title, saves $30 in 2 months, because 30 is the amount of dollars on the y-axis and 2 is the number of months on the x-axis. The pink dot is located here. That is at the coordinate 115. And that means that Miguel saves $15 every month. And the green dot is located here at the coordinate 460. And that coordinate means that he saves $60 every 4 months. The constant of proportionality here is 15. If I do any of my y's divided by x, I would get 15. And that is the unit rate, which means that he earns he saves $15 per month. The equation for this situation would be that y equals 15x. All right, next, this table shows various amounts of a fruit punch recipe. So first it's asking what is the constant of proportionality. So all I would need to do is y divided by x. So in this case, it could be 2 divided by 7. That could be written as 2/7, or if you do 2 divided by 7 in your calculator, you get 0.2857. Okay, this unit rate means that 2/7 cups of peach juice will be used for every 1 cup of grape juice, because if grape juice was 1, we would do 1 times 2/7, and peach juice would be 2/7. Okay, the equation for this table is y equals 2/7 x. All right, next we're going to write an equation for this situation. A grocery store charges 50 cents per donut. Which equation can be used to find C, the total cost in dollars, to buy D, number of donuts? This one's pretty straightforward. The total cost is equal to 0.5 times the number of donuts. And then lastly, Harrison pays $20 per t-shirt at a local clothing store. The equation shown could be used to calculate the total cost of his purchases. So the total cost is equal to 20 times something. Well, the question's asking what does X represent in this equation. Since it's $20 per t-shirt, I know it's $20 times the number of t-shirts he bought would give me the total cost. All right, remember you can always go back and pause this video for each section to help you. Good luck.